Okay, I'm Oliver. This is joint work with Chow and our advisor Jim. For hypersonic flows, which could be more than, say, Mach 25, heat transfer becomes increasingly critical because the temperature can become extremely high, more than, say, 5,000 degrees Kelvin. Gases will dissociate and ionize. A good example of which all of you know of is the space shuttle. The space shuttle needs heat shielding so that it doesn't burn up in the atmosphere when it re-enters. The particular defense application that we're interested in is hypersonic missiles. For those, you need to protect the guidance electronics and payloads within the missile. Of course, after the missile has already been built, you will need to do further experimental tests. But during the design phase, it's more time efficient and cost efficient to run simulations. So that's what we did. And to do that, we coupled fluid and solid solver codes, by exchanging data between them at the fluid-solid interface. That's the schematic. Software adapters that we've written include those for overflow, which is a NASA finite difference CFD code for overlapping meshes, shown here, and also for Abacus, which is a popular commercial finite element solid mechanics solver. To ensure the continuity of temperature and heat flux across the interface, what we did was we took a temperature in the solid, mapped it to the fluid to apply as Dirichlet boundary conditions, and took a heat flux from the fluid to map back to the solid as Neumann boundary conditions. And in each coupling step, we also do subcycling in the fluid, and we also do predictor-corrector iterations to increase stability of the coupling. Our mapper is designed to work for an arbitrary number of solid and fluid mesh partitions and MPI processes. A simple test case for a heat transfer is a laminar flow over a heated flat plate, which is shown here. And for that case, there's an approximate analytical solution, and we verified that our coupler indeed produces the correct temperature along the interface. For a more complicated test, NASA has a hypersonic blowdown tunnel at Langley, shown here, and they've done some experimental measurements of Mach 6 flows over steel cylinders, right here. And so we chose to do a mesh convergence study for this case, meshes here, and we found that our coupler indeed produces the correct normalized heat flux along the interface here. Matches the experimental data. Thanks. Okay, all right, that's good enough. My poster is in the lobby.